Which of the following set have different dimensions? Okay, so we have to find the dimension of each of these physical quantities and check if these are equal. Okay, so we have four options here. So let's first check the first option. So the first physical quantity is pressure. So pressure, we know that pressure is force per unit area. Okay, force can be written as mass into acceleration. So this will be ma divided by a. So we can try to find the dimensional formula. Mass is m, acceleration is L t power minus 2, because the unit is meter per second square, so you can get the dimension from that. So this will be L t power minus 2 by the area is L square. Okay, so this will be m L raised to minus 1 t power minus 2. Just cancel the L here. Now m L raised to minus 1 t power minus 2. Okay, now that is the dimension for pressure. Now let's find uh, Young's modulus. Young's modulus is stress divided by strain. Okay, let's try to find the dimension formula of stress also. Okay, stress is also given as force per area, so its dimension will be same as that of the pressure. Okay, now we have to find the Young's modulus. Young's modulus is stress by strain. So stress is given as force by area, strain is delta L by L. So this will be F by A into L by delta L. Now we already found F by A, that is m L raised to minus 1 t power minus 2. Now L by delta L is a dimensionless quantity, right? L, because both are length, so it's a dimensionless quantity. So now again we have got the dimension of Young's modulus as the same as the dimension of pressure, that is same as the dimension of stress. So all these three quantities have the same dimension. Okay, now what about the second option? EMF, potential difference, and electric potential. Now there is a relation connecting all these things, that is EMF E is equal to terminal potential difference minus I into internal resistance. E is equal to V minus IR. Okay, E is equal to V minus IR. Now from this equation we know that EMF, so before that there is a principle called principle of homogeneity of dimensions. Principle of homogeneity of dimensions, which means that if there is a relation like A is equal to B plus C, all the terms in the equation have the same dimension. So dimension of A is equal to the dimension of B is equal to the dimension of C. So in this case the dimension of EMF is same as the dimension of terminal potential difference. Okay, so we have EMF and terminal potential difference having the same dimension. Also the terminal potential difference can be written as V plus minus V minus. Okay, because terminal potential difference is the potential difference across the terminals of a battery. So the positive terminal has the potential V plus, negative terminal has the potential V minus. So the terminal potential difference is V is equal to V plus minus V minus when current I is flowing through it. Okay, now V plus is the electric potential at positive terminal. Similarly, V minus is the electric potential at negative terminal. Okay, so from this we can say that the dimension of EMF is same as the dimension of potential difference is same as the dimension of potential at the positive terminal. Okay, now what about the third relation? Heat, work done, and energy. Okay, again we can make use of a relation, that is there is a relation, that is the second law of thermodynamics, delta Q is equal to delta U plus P into delta V. Okay, so delta Q is actually the heat, delta U is the internal energy, and P into delta V is the work done. Okay, so these three quantities have the same dimension according to the principle of homogeneity of dimensions, because these three are connected in an equation, so these three have the same dimensions. So option A, B, C have the same dimensions. Now what about option D? Option D, the quantities are having different dimensions. So first of all, what dipole moment? Dipole moment is defined as P is equal to charge into length, Q into L. Okay, so charge q can be written as I by t. Sorry, I is written as q by t, and q can be written as I into t. So this will be I into t into L. Okay, that is the dipole moment. Now what about electric flux? Electric flux is E into A. E A cos theta. Cos theta is dimensionless, so this will be E into A. Okay. Also we have a relation F is equal to QE. Now E can be written as F divided by Q. So this will be F divided by Q into A. Okay. Now we know the dimension of F is M L T power minus 2, and Q is again we have to substitute. Q is current into time, I into T, and into area. Area is L square. So this will be M. Current is represented by ampere, so it will be a raised to minus 1 L cube t power minus 3. You can see that the dimension of the second quantity, that is the electric flux, is different from the first quantity, that is the dipole moment is defined as current is ampere, t, time is t, and L is L. Okay, so this is the dimension of the dipole moment. So these quantities have different dimensions. So option D is the correct option. So option D is having different dimensions for each physical quantities. Hope you understood this solution. Thank you.